Hello, in this lecture we will find out the values of line segments X and Y. In the drawing we have square ABCD. In the drawing we have square DEBF. And one side of square DBEF is equal to 1 unit, so all of its sides are equal to 1 unit, and square DEBF is inside the right triangle ABC, and we know that the hypotenuse AC of the right triangle ABC equals to 3 units, and we want to find out the value of line segment FC that equals to X and line segment AD that equals to Y. Okay, so first of all we have a rule that states that the opposite sides of a square are parallel to each other. That is to say, in square DEBF, this square, DE is parallel to BF, DE is parallel to BF, and we also know that BC is one side of the right triangle ABC. Therefore, BC, it is absolutely a straight line. So we can write down that BC is a straight line and part of the straight line BC, that is actually BF, is parallel to DE. So if part of a straight line is parallel to DE, then the straight line itself BC will be also parallel to DE. So BC, the straight line BC, is also parallel to DE. Again, if part of a straight line is parallel to another straight line, then the straight line itself will be also parallel to that straight line. Therefore, BC is parallel to DE. And we also have rule number 1. According to rule number 1, corresponding angles between parallel lines are equal to each other. Corresponding angles between parallel lines are equal to each other. I will read rule number 1 again. According to rule number 1, corresponding angles between parallel lines are equal to each other. So actually here we have in the drawing those two angles are defined as corresponding angles. That is to say, angle AED and angle ECF. Those two angles are defined as corresponding angles, and those two angles are located between the parallel lines DE and BC. That is to say, DE is parallel to BC. Therefore, according to rule number 1, they are equal to each other. That is to say, angle AED equals to angle ECF according to rule number 1. I will write it down. Angle AED, this angle is equal to angle ECF. This angle according to rule number 1. I will repeat again. Angle AED equals to angle ECF according to rule number 1, because of the fact that those two corresponding angles are located between the parallel lines DE and BC, they are equal to each other. And if we define angle AED as theta, so here we can write down that angle AED equals to theta according to our definition. From this equation, theta equals to angle AED equals to angle ECF, we will derive that angle ECF also equals to theta. Angle ECF also equals to theta. We can write here that angle ECF equals to theta. So we found out that those two angles that are equal to each other, they are both equals to theta. In the next step, I will present to you a new rule, rule number 2. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. I will write it down. The sum of the angles on one side of a straight line is equal to 180 degrees. I will read rule number 1 again. According to rule number 1, the sum of the angles on one side of a straight line is equal to 180 degrees. So here AB is one side of the right triangle, triangle ABC, therefore it is absolutely a straight line. AB is one side of a triangle, it must be a straight line, so AB is a straight line. And if we focus on this side of the straight line AB at point D, then the sum of the angles must be equal to 180 degrees according to rule number 2. So if we define angle ADE, this angle is angle X, then at point D on this side of the straight line AB, 90 degrees plus the size of angle X. In total, the sum of those two angles must be equal to 180 degrees according to rule number 2. So 90 degrees plus the size of angle X must be equal to 180 degrees according to rule number 2. So here we will subtract 90 degrees from this equation and we will get that angle X equals to 180 degrees minus 90 degrees, that is to say it equals to 90 degrees. So we found out that angle X is a right angle, it equals to 90 degrees. So we will substitute angle X by a right angle. So because of the fact that angle ADE equals to 90 degrees, then triangle ADE is a right triangle. Likewise, BC is one side of the right triangle, triangle ABC, therefore it is a straight line. So you can write down that BC is a straight line. And if we focus on the upper side of the straight line BC at point F, then the sum of the angles must be equal at point F to 180 degrees. So if we define angle EFC as angle Y, then the size of angle Y plus 90 degrees must be equal to 180 degrees according to rule number 2. So I write it down. Angle Y plus 90 degrees must be equal to 180 degrees according to rule number 2. Here we will subtract 90 degrees from this equation and we will get that angle Y equals to 180 degrees minus 90 degrees is 90 degrees. So we found out that angle Y is a right angle, it equals to 90 degrees. So we'll substitute angle Y to a right angle. And triangle EFC is a right triangle. In the next step, we will focus on the right triangle, triangle ADE. On the right triangle, triangle ADE. Tangent theta equals to AD over DE. I repeat again, in the right triangle, triangle ADE, tangent theta equals to AD over DE. AD equals to Y according to what is given us in the question. And DE equals to 1 unit. So in conclusion, we found out that tangent theta according to equation number 1 equals to Y. Okay. Tangent theta according to equation number 1 equals to Y. In the next step, we will focus on triangle EFC, the right triangle EFC. On the right triangle, triangle EFC, tangent theta equals to EF over FC. EF equals to, so I repeat again, in the right triangle, triangle EFC, tangent theta equals to EF over FC. According to equation number 2, here EF equals to 1 unit, and FC equals to X according to what is given us in the question. So in conclusion, we found out that tangent theta, according to equation number 2, equals to 1 over X. Now we will create equation number 3 that states that tangent theta according to equation number 1 must be equal to tangent theta according to equation number 2. Okay, so equation number 3 states that tangent theta according to equation number 1 that actually equals to Y must be equal to tangent theta according to equation number 2, that according to equation number 2 equals to 1 over X. So we actually got equation number 3 states that Y equals to 1 over X. That is to say, Y is the inverse number of X and X is the inverse number of Y. If we multiply equation number 3 by X, we will get that Y times X equals to 1. Again, whenever you have two numbers, when the multiplication of two numbers by each other is equal to 1, it means that each one is the inverse number of the other one. Okay? So we can write here that X is the inverse number of Y. And it is also true to say that Y is the inverse number of X. Y is the inverse number of X. Okay, and it is very important to remember that every number has only one inverse number. Okay, so I will write it down. Every number has only one inverse number. The inverse number of 5 is 1 over 5 and only 1 over 5. Number 5 has no other inverse number but only 1 over 5, and the inverse number of 1 over 5 is 5 and not any other number. Okay, so in the next step we will focus on the right triangle, triangle ABC. On the right triangle, triangle ABC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle, triangle ABC is AC, and the square of the hypotenuse is AC squared, and it equals to the sum of the squares of the perpendiculars, that is to say it equals to AB squared plus BC squared. So I repeat again, in the right triangle ABC, according to the Pythagoras theorem, the letters P and T is the abbreviation for Pythagoras theorem. So according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say AC squared equals to AB squared plus BC squared. Here we know that it is given us in the question that AC equals to 3 units, therefore AC squared equals to 3 squared. 3 squared is 9, and 9 equals to AB squared. AB equals to y plus 1, so AB squared is y plus 1 squared, plus BC squared. BC equals to x plus 1, so BC squared will be equal to x plus 1 squared. So in conclusion, we got that according to equation number 4, 9 equals to y plus 1 squared plus x plus 1 squared. Here we will open the brackets on this side of equation number 4, and we will get that y plus 1 squared is equal to y squared plus 2y plus 1, and x plus 1 squared equals to x squared plus 2x plus 1, and in the other side of the equation we have, equation number 4, we have 9, so it equals to 9. But according to equation number 3, we have already found out that y equals to 1 over x. Therefore, we can substitute y in equation number 4 by 1 over x. We will do it now, and we will get that according to equation number 4, y squared, y is 1 over x, so y squared is 1 over x squared, plus 2y, plus 2 times y is 1 over x, so it is 2 times 1 over x, plus 1 plus x squared, plus 2x plus 1 equals to 9. Here we will organize the expressions in equation number 4 in a different way, and we'll get that x squared plus 1 over x squared plus 1 plus 1 is 2, plus 2, plus 2x, plus 2 times 1 over x. Here we'll subtract 9 from equation number 4, so it will be minus 9 equals to 0. In the brackets, x squared plus 1 over x squared plus 2, this expression equals to x plus 1 over x squared. According to the rule that a plus b squared equals to a squared plus b squared minus 2 times ab, so it is x plus 1 over x squared. And here we will take 2 as a common factor out of those two expressions, and inside the brackets we will have here x plus 1 over x minus 9 equals to 0. So here we will define x, plus 1 over x. Here we will define x plus 1 over x as t, that is to say t equals to x plus 1 over x according to our definition. So according to equation number 4, we have x plus 1 over x squared. It will be t squared plus 2 times x plus 1 over x, that is actually 2t, minus 9 equals to 0. So here we have a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to the following formula, according to the formula that x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, t squared plus 2t minus 9 equals to 0, the variable that we are looking for is t, so x equals to t. The coefficient a equals to 1 unit, the coefficient b equals to 2 units, and c equals to minus 9. So the only thing that is left to do is to put the data that we have inside the formula of x in order to find out the value or the values of t. So x equals to t, so we get that t equals to minus b, b equals to 2, so minus b will be equal to minus 2 plus minus square root of b squared. B equals to 2, so b squared is 2 squared, 2 squared is 4, minus 4 times A times C. A equals to 1, so minus 4 times minus 1 is minus 4, and minus 4 times C, that is minus 9, is plus 36. So inside the brackets we have 4 plus 36 over 2A. A equals to 1, so 2A is 2 times 1 is 2. So in conclusion, we found out that T equals to minus 2 plus minus 4 plus 36 is 40. So inside the root we have 40 over 2. But 40 is 4 times 10, and the square root of 4 is 2. So here we will get that T equals to minus 2 plus minus 2 times the square root of 10 over 2. So here we will have two solutions that are possible for T. But first of all, we will divide. Here we have T equals to minus 2 over 2 is minus 1, plus minus 2 over 2 is 1, so it is plus square root of 10. And here we will have two solutions that are possible for T. The first solution for T is T equals to minus 1 plus square root of 10. And the second solution that we will get here is T equals to minus 1 minus square root of 10. But according to our definition, T equals to x plus 1 over x. So x plus 1 over x, according to the second solution, equals to minus 1 minus square root of 10. And here x is one side of the right triangle EFC. So x is a length, and the length is a positive number. So if x is a positive number, x plus 1 over x will be also a positive number. So in this side of the equation we have a positive number. And in the other side of the equation we have the expression minus 1 minus square root of 10 units. Minus 1 minus square root of 10 units is a negative number. And a negative number can never be equal to a positive number, so there is a contradiction here. Therefore, this solution is the incorrect solution. We will cancel this solution, and we left only with the solution that T equals to minus 1 plus square root of 10. Again, T equals to x plus 1 over x according to our definition, and it equals to minus 1 plus square root of 10 here. We will multiply x by x, and then we will divide it by x in order to have a common factor with 1 over x. And we will get that x squared plus 1 over x equals to square root of 10 minus 1. So here we'll multiply the equation by x, and we will get that x squared plus 1 equals to square root of 10 minus 1 times x. Here we will subtract square root of 10 minus 1 times x from this equation, and we'll get that x squared minus square root of 10 minus 1 times x plus 1 equals to 0. So we got here a quadratic equation. In this quadratic equation, a equals to 1, b equals to minus square root of 10 minus 1, and c equals to 1. And the solution for the quadratic equation, the general formula for it is x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. So, in our specific quadratic equation, the value or the values of x will be as follows. X will be equal to minus b, b equals to minus square root of 10 minus 1, so minus b will be minus minus square root of 10 minus 1, that is to say it will be equal to square root of 10 minus 1 plus minus b squared will be equal to square root of 10 minus 1 squared minus 4 times a times c. A is 1, c is 1, so it will be equal to minus 4 over 2a. A is 1, so 2 times 1 is 2, so it is over 2. So x equals to square root of 10 minus 1 plus minus, here we have square root of 10 minus 1 square. We will find out the value of this expression according to the algebraic identity that states that a minus b square equals to a square plus b square minus 2 times ab. So it will be equal to a squared, that is square root of 10 squared, that is 10, plus b squared, that is plus 1 squared, that is 1, minus 2 times square root of 10 minus 4 all divided by 2. So we get that x equals to square root of 10 minus 1 plus minus, inside the root we have 10 plus 1 is 11, 11 minus 4 is 7, so inside the root we have 7 minus 2 times square root of 10, all divided by 2. So here we will find out the value of the expression inside the root, that is actually 7 minus 2 times square root of 10. Seven minus Actually, we will change the expression inside the root that is actually 7 minus 2 times square root of 10. It is actually equals to 7 is 5 plus 2, so we substitute 7 by 5 plus 2 minus 2 times square root of 10, and we'll substitute square root of 10 by square root of 5 times square root of 2. Here 5 is actually square root of 5 square, so we substitute 5 by square root of 5 square, and 2 is square root of 2 square, so we will substitute 2 by square root of 2 square, minus 2 times square root of 5 times square root of 2, the expression square root of 5 square plus square root of 2 square minus 2 times square root of 5 times square root of 2 is very similar to the algebraic identity that a square plus b square minus 2 times ab equals to a minus b square. That is to say, we can change this our specific expression to a minus b square, and in our specific expression a equals to square root of 5 and b equals to square root of 2. So we will do it now, and we get that our expression equals to square root of 5 minus square root of 2 square. So actually we found out that the expression 7 minus 2 times square root of 10 equals to square root of 5 minus square root of 2 square. Therefore, we will substitute the expression that is inside the square that is actually 7 minus 2 times square root of 10 by the expression of square root of 5 minus square root of 2 square. We'll do it now, and we'll get that x equals to square root of 10 minus 1 plus minus, and instead of 7 minus 2 times square root of 10, we will write down square root of 5 plus square root of 2 square, all divided by 2. So we got here that x equals to square root of 10 minus 1 plus minus. So here we have actually square root of 5 plus square root of 2 square and root. The square cancels the root, and we will left only with square root of 5 plus square root of 2, all divided by 2. So we will have here two solutions that are possible for x. The first solution, we will define the first solution as x1 and the second solution as x2. So the first solution, x1, will be equal to square root of 10 minus 1 plus square root of 5 plus square root of 2. This is the first solution. And the second solution for x will be equal to x2. And x2 will be equal to square root of 10 minus 1 minus square root of 5 plus square root of 2. Here it is actually inside the root. Here we have square root of 5 minus square root of 2, so it is here it is minus, and here it is also minus. So here inside the root we have square root of 5 minus square root of 2, all divided by 2. So x1 and x2 are the two solutions for x of the quadratic equation. We'll start with x1. We will simplify the expression for x1, and we get that x1 equals to square root of 10 minus 1 plus square root of 5 plus square root of 2 over 2. Here we will substitute square root of 10 by square root of 5 times square root of 2, and we get that x1 equals to square root of 10 is square root of 5 times square root of 2 minus 1 plus square root of 5 plus square root of 2. Here it is actually square root of 5 minus square root of 2, square root of 5 minus square root of 2, and here also it is square root of 5 minus square root of 2, all divided by 2. So we got here that x1 equals to, here we'll take square root of 5 as a common factor. Square root of 5 is a common factor, so inside the brackets we'll have here square root of 2 plus 1. And we here, from those two expressions, we take out minus 1 as a common factor, so it will be minus. And inside the brackets we will have square root of 2 plus 1, all divided by 2. So we got here that x1 equals to, so square root of 2 plus 1 will be taken as a common factor, and inside the root we have square root of 5 minus 1, all divided by 2. So in conclusion we found out that x1 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. We'll do the same process for x2. We'll simplify the expression for x2, and we get that x2 equals to square root of 10 minus 1 minus square root of 5. Here we have minus, and minus is plus, so it will be plus square root of 2 divided by 2. So we get here that x2 equals to, here square root of 10 is square root of 5 times square root of 2, so we substitute square root of 10 by square root of 5 times square root of 2. Minus 1 minus square root of 5 plus 2 plus square root of 2, all divided by 2. So x2 equals to, we take out square root of 5 as a common factor out of this expression, and inside the brackets we will have here square root of 2 minus 1 plus square root of 2 minus 1 divided by 2. So x2 equals to, we take out square root of 2 minus 1 as a common factor out of this expression, and inside the brackets we will have here square root of 5 plus 1 all divided by 2. So we found out, in conclusion, we found out that x2 equals to square root of 2 minus 1 times square root of 5 plus 1 divided by 2, and x1 equals to square root of 2 plus 1 times square root of 5 minus 1 divided by 2. In the next step, we will multiply x1 by x2, but first of all, I will copy to this new page the values of x1 and x2. We actually found out that x1 equals to square root of 2 plus 1 times square root of 5 minus 1 all divided by 2, and x2 equals to square root of 2 minus 1 times square root of 5 plus 1 all divided by 2. In the next step, we will multiply x1 by x2. So x1 times x2 will be equal to square root of 2 plus 1 times square root of 5 minus 1 over 2 times x2, that is square root of 2 minus 1 times square root of 5 plus 1 all divided by 2. Here we will organize the expressions in this x1 times x2 in other order, and we'll get that x1 times x2 equals to square root of 2 plus square root of 1 times square root of 2 minus square root of 1 times square root of 5 plus 1 times square root of 5 minus 1 all divided by 2 times 2. So we'll find out the value of square root of 2 plus 1 times square root of 2 minus 1 according to the algebraic identity, that states that a plus b times a minus b equals to a squared minus b squared. In our specific expression, a equals to square root of 2 and b equals to 1. So we know that square root of 2 plus 1 times square root of 2 minus 1 must be equal to a squared minus b squared, and a is equal to square root of 2, so a squared is square root of 2 squared. Square root of 2 squared is 2 minus b squared. B equals to 1, so b squared is 1 squared, 1 squared is 1, so minus b squared is minus 1. So in conclusion, we found out that square root of 2 plus 1 times square root of 2 minus 1 equals to 2 minus 1, that is actually 1. In the same way, we will find out the value of the multiplication of square root of 5 plus 1 times square root of 5 minus 1. Here a equals to square root of 5 and b equals to 1. So this expression must be equal to a squared minus b squared. A is square root of 5, so a squared is square root of 5 squared is 5, minus b squared, b is 1, so b squared is 1 squared, 1 squared is 1, so minus b squared is minus 1. So in conclusion, we found out that square root of 5 plus 1 times square root of 5 minus 1 equals to 5 minus 1. That is actually minus 4. So here we can write down that x1 times x2 equals to 2 minus 1 times 5 minus 1 over 2 times 2, that is 4. 2 minus 1 is 1, 5 minus 1 is 4. 1 times 4 is 4, and 4 over 4 is 1. So we actually found out that x1 times x2 is 1. x1 times x2 is 1. So I can write here that x1 times x2 is 1. What does it mean? It means that x1 is the inverse number of x2, and it also means that x2 is the inverse number of x1. Okay, but according to equation number 3, we found out that x times y equals to 1. It also means that x is the inverse number of y and y is the inverse number of x. But if we put the solutions for x and y inside equation number 3, the first solution will be x1 y1. So x will be equal to x1 and y will be equal to y1, and we'll get that x1 times y1 equals to 1. What does it mean? It means that y1 is the inverse number of x1. Okay, but we have already found out that x2 is the inverse number of x1. So we have two numbers that are the inverse number of x1. But according to the rule that each number has only one inverse number, we will conclude that if we have two numbers that are the inverse numbers of a specific number, they must be equal to each other. That is to say, y1 is equal to x2. Okay, so we found out that y1 equals to x2, and in the same way, the second solution for the quadratic equation is x2, and y2 is the value of that will be received after we put the value of x2 inside the equation number 3. So x2 and y2 is the second solution, and the equation number 3 states that x times y equals to 1. Here we will put the value of x inside x, so x equals to x2 and y equals to y2, and we will get that according to equation number 3, x2 times y2 equals to 1. So what does it mean that x2 times y2 equals to 1? It means that y2 is the inverse number of x2. y2 is the inverse number of x2, but we have already found out that x1 is the inverse number of x2. And again, because of the fact that each number has only one inverse number, x2 has only one inverse number. So, therefore, we must include that y2 equals to x1 because of the fact that each number, including x2, has only one inverse number. So if you have two numbers that are equal to the inverse number of a specific number, that is to say x2, they must be equal to each other. That is to say y2 equals to x1, and we have already found out that y1 equals to x2. Now we can present the two solutions of the question. The first solution will be x1, y1. And we have already found out that x1 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2, and y2 equals to and y1, so this is x1, and y1, we have already found out that y1 equals to x2. Okay, so y1 is x2, that is actually square root of 2 minus 1 times square root of 5 plus 1 over 2. Okay, this is the first solution to the question, and the second solution is x2, y2. x2 actually equals to square root of 2 minus 1 times square root of 5 plus 1 over 2, and we have already found out that y2 equals to x1. and x1, it is actually square root of 2 plus 1 times square root of 5 minus 1, all divided by 2. Okay, so those are the two solutions for the question, and in the next step I will summarize the lecture. We actually wanted to find out the value of x and y, and we have here square DEBF. One side of square DBEF equals to 1 unit. The square is inside the right triangle, triangle ABC, and the hypotenuse AC of the right triangle, triangle ABC equals to 3 units. And we want to find out the value of the values of line segment FC that equals to x and line segment AD that equals to y. So first of all, we know that the opposite sides of a square are parallel to each other. That is to say, DE is parallel to BF. Okay, DE is parallel to BF. And we know that BC is one side of the right triangle, triangle ABC, therefore it is a straight line. So we know that also that BC is a straight line. And because of the fact that BF, that is part of BC, is parallel to DE, therefore, so if part of the straight line BC is parallel to DE, then BC itself will be also parallel to DE. Okay? If part of a straight line is parallel to another straight line, then the straight line itself will be also parallel to that line. That is to say, BC also parallel to DE. And we have rule number 1 that says that corresponding angles between parallel lines are equal to each other. So here, those two angles are defined as corresponding angles, and they are located between the parallel lines DE and BC, therefore they are equal to each other. That is to say, angle AED equals to angle ECF. Those two angles are equal to each other, according to rule number 1. And if we define angle AED as theta, if angle AED equals to theta, from this equation we will derive that angle ECF also equals to theta. This angle ECF also equals to theta. So we found out that those two angles, they are equal to each other and they are both equal to theta. And then I presented to you rule number 2. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. So here we have side AB is one side of the right triangle, triangle ABC, therefore it is absolutely a straight line. Okay, AB is a straight line, and according to rule number 2, if we focus on this side of the straight line AB at point D, then the sum of the angles at point D must be equal to 180 degrees. So if we define angle AD as x and this angle is 90 degrees, the sum of those two angles x at 90 degrees must be equal to 180 degrees. So here 90 degrees plus x must be equal to 180 degrees according to rule number 2. We subtracted 90 degrees from this equation and we found out that angle x equals to 180 degrees minus 90 degrees, that is to say angle x equals to 90 degrees. So this angle is a right angle. Likewise, BC is one side of the right triangle, triangle ABC, therefore it is absolutely a straight line. And if we focus on the upper side of the straight line BC at point F, then the sum of the angles at point F must be equal to 180 degrees. If we define angle EFC as y, and this angle is 90 degrees, the sum of those two angles must be equal to 180 degrees according to rule number 2. So angle y plus 90 degrees must be equal to 180 degrees according to rule number 2. We subtracted 90 degrees from this equation and we found out that angle y equals to 180 degrees minus 90 degrees, that is to say angle y equals to 90 degrees. So angle y is a right angle. Then we focused on the right triangle, triangle ADE. On the right triangle, triangle ADE, we know that angle theta equals to AD over DE. In the right triangle, triangle ADE, tangle theta equals to AD over DE. AD equals to y, DE equals to 1. So in conclusion, we found out that tangle theta, according to equation number 1, equals to y. Then we focused on the right triangle, triangle EFC. On the right triangle, triangle EFC, tangle theta equals to EF over FC. Tangle theta equals to EF over FC. But EF equals to 1, FC equals to x. So in conclusion, we found out that tangle theta equals to 1 over x according to equation number 2. Then we created equation number 3 that states that tangle theta according to equation number 1 must be equal to tangle theta according to equation number 3. So equation number 3 states that tangle theta according to equation number 1 that equals to y must be equal to tangle theta according to equation number 2 that equals to y over x. So according to equation number 3, y equals to 1 over x. We multiply the equation number 3 by x, and we got that y times x equals to 1. What does it mean? When you multiply two numbers by each other and you got 1, it means that x is the inverse number of y, and y is the inverse number of x. And we have also another rule that every number has only one inverse number. The inverse number of 5 is 1 over 5 and only 1 over 5. And the inverse number of 1 over 5 is only 5. It's 5 and only 5. So then we focus on the right triangle, triangle ABC. In the right triangle, triangle ABC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AC, so the square of the hypotenuse is AC squared. And AC squared equals to the sum of the squares of the perpendiculars, that is to say it equals to AB squared plus BC squared. AC equals to 3 units. AC squared will be equal to 3 squared, that is to say it will be equal to 3 squared is 9, so it will be equal to 9. And AC squared equals to AB squared. AB is y plus 1, so AB squared is y plus 1 squared plus BC squared. BC is x plus 1, so BC squared is x plus 1 squared. So in conclusion, we found out that according to equation number 4, 9 equals to y plus 1 squared plus x plus 1 squared. Here we open the brackets on this side of equation number 4, and we got that y plus 1 squared equals to y squared plus 2y plus 1 plus x plus 1 squared. X plus 1 squared equals to x squared plus 2x plus 1. And this side of the equation equals to 9. Then, according to equation number 3, y equals to 1 over x. So we can substitute y in equation number 4 by y or by 1 over x. We did it, and we got that y squared is 1 over x squared plus 2y is 2 times y 1 is 2 times 1 over x plus 1 plus x squared plus 2x plus 1 equals to 9. Here we organized the expressions in equation number 4 in a different way, and we got that x squared plus 1 over x squared plus 2 plus 2x plus 1 over plus 2x plus 2 over x minus 9 equals to 0. Inside the brackets, this expression equals to x plus 1 over x squared. So we substituted this expression by x plus 1 over x squared. And here we took 2 as a common factor of from those two expressions. And inside the root, we left only with x plus 1 over x minus 9 equals to 0. We define t as x plus 1 over x, that is to say t equals to x plus 1 over x according to our definition. Then we substituted x plus 1 over x in equation number 4 by t, and we got that here we have t squared plus 2t squared minus 9 equals to 0. So here we got the quadratic equation. And the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. A, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to a special formula. The formula is x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, t squared plus 2t minus 9 equals to 0, a equals to 1, b equals to 2, and c equals to minus 9. And the variable that we are looking for is t, that is to say x equals to t. So we put the data inside the formula for x, and we found out that t equals to minus b. b is 2, so minus b is minus 2, plus minus b squared. b is 2, so b squared is 2 squared, 2 squared is 4, minus 4 times a times c. This minus 4 times 1 is minus 4, times minus 9, minus 4 times minus 9 is plus 36, so inside the brackets, inside the root we have 4 plus 36, all divided by 2. So t equals to minus 2 plus minus 36 plus 4 is 40 over 2. And 40 is 4 times 10. The square root of 4 is 2, so 2 we get out of the root, and inside the root we left only with square root of 10, that is to say t equals to minus 2 plus minus 2 times square root of 10 over 2. So here 2 minus 2 over 2 is minus 1, and 2 over 2 is 1. So in conclusion, we found out that t equals to minus 1 plus minus square root of 10. So here we will have two solutions that are possible for t. The first solution is t equals to minus 1 plus square root of 10, and the second solution for t is t equals to minus 1 minus square root of 10. Then we focused on the second solution. T, according to our definition, is equal to x plus 1 over x, and it equals to the expression minus 1 minus square root of 10. T is one side of this right triangle, that is to say it is a length. T as a length, it must be a positive number, therefore x plus 1 over x is a positive number, while minus 1 minus square root of 10 is a negative number. And because of the fact that the positive number can never be equal to a negative number, we got to a contradiction. Therefore, this possibility is not true. This solution is incorrect solution, and we left only with the solution that t equals to minus 1 plus square root of 10. T, according to our definition, equals to x plus 1 over x, and it equals to minus 1 plus square root of 2. Here we multiplied x by x, and then we divided by x, and we got that x squared plus 1 over x equals to square root of 10 minus 1. Here we multiplied the equation by x, and we got that x squared plus 1 equals to square root of 10 minus 1 times x, Here we subtracted square root of 10 minus 1 times x from this equation, and we got that x squared minus square root of 10 minus 1x plus 1 equals to 0. So this is a quadratic equation. The coefficient a equals to 1, the coefficient b equals to minus square root of 10 minus 1, and c equals to 1, and the general solution for quadratic equation is x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. So we put the data inside the formula for x, and we found out that x equals to minus b. Minus b is square root of 10 minus 1 plus minus b squared. B squared is square root of 10 minus 1 squared. Minus 4 times ac is minus 4. Over 2a is over 2. So x equals to square root of 10 minus 1 plus minus. Here we have square root of 10 minus 1 squared. We found the value of this expression according to the formula that a minus b squared equals to a squared plus b squared minus times 2ab. A squared is a square root of 10, so a squared is square root of 10 squared, that is 10. B is 1, so b squared is 1 squared, that is 1. So we got here 10 plus 1 minus 2 times ab is minus 2 times square root of 10 minus 4, all divided by 2. So x equals to square root of 10 minus 1 plus minus. Here 10 plus 1 is 11, 11 minus 4 is 7. So here we'll have 7 minus 2 times square root of 10, all divided by 2. So inside the root we have 7 minus 2 times square root of 10, and we change this expression to another form. So inside the root we have the expression of 7 minus 2 times square root of 10. This expression equals to 7 is 5 plus 2. So we substituted 7 by 5 plus 2. And minus 2 times square root of 10. And square root of 10 is square root of 5 times square root of 2. So we substituted square root of 10 by square root of 5 times square root of 2. And we got here 5 plus 2 minus 2 times square root of 5 times square root of 2. 5 is square root of 5 squared, and 2 is square root of 2 squared. So in conclusion we got that square root of 5 squared plus square root of 2 squared minus 2 times square root of 5 times square root of 2 equals to 7 minus 2 times square root of 10. This expression is very similar to the algebraic identity that states that a squared plus b squared minus 2 times ab equals to a minus b squared. That is to say, we can change this expression by a minus b squared when a equals to square root of 5 and b equals to square root of 2. So we did it, and we got that square root of 5 minus square root of 2 squared equals to this expression that equals to this expression. So in conclusion, we found out that 7 minus 2 times square root of 10 equals to square root of 5 minus square root of 2 squared. That is to say, we can substitute the expression inside the root, that is 7 minus 2 times square root of 10, by the expression that is actually square root of 5 minus square root of 2 squared. We did it, and we got that x equals to square root of 10 minus 1 plus minus, and again we substituted the expression of 7 minus 2 times square root of 10 by the expression square root of 5 minus square root of 2 squared, all divided by 2. Here the square cancels the root, and we left only with square root of 5 minus square root of 2. So in conclusion we got that x equals to square root of 10 minus 1 plus minus square root of 5 minus square root of 2 over 2. So here we will have two solutions that are possible for x. The first solution will be defined as xy as x1, and the second solution will be defined as x2. So the first solution is x1 equals to minus square root of 10 minus 1 plus square root of 5 minus square root of 2 over 2. And the second solution is x2, that is actually square root of 10 minus 1 minus square root of 5 minus square root of 2 over 2. So we will continue with the first solution, x1. Here we will have square root of 2 minus 1 plus square root of 2 minus square root plus square root of 5 minus square root of 2 over 2. Here we substituted square root of 10 by square root of 5 times square root of 2, and we got that x equals to square root of 5 times square root of 2 minus 1 plus square root of 5 minus square root of 2 over 2. Here we took square root of 5 as a common factor out of this expression, and we got that x1 equals to square root of 5 is a common factor, and inside the brackets we will have square root of 5, square root of 2 plus 1 minus square root of 2 plus 1 over 2. Here we took square root of 2 plus 1 as a common factor, and inside the brackets we have here x1 equals to square root of 2 plus 1 is a common factor, and inside the brackets we have square root of 5 minus 1 over 2. So in conclusion, we found out that x1 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. Then we did the same process for the second solution, x2. x2 equals to square root of 10 minus 1 minus square root of 5 minus square root of 2 over 2. Here we open the brackets, and we got that x2 equals to square root of 10 minus 1 minus square root of 5. Here minus and minus is plus, so here we have plus square root of 2 over 2. Here we substituted square root of 10 by square root of 5 times square root of 2, and we got that x2 equals to square root of 5 times square root of 2 minus 1 minus square root of 5 plus square root of 2 over 2. Here we took square root of 5 as a common factor out of this expression, and we got that x2 equals to square root of 5, and inside the brackets we have square root of 2 minus 1 plus square root of 2 minus 1 over 2. Here we took square root of 2 minus 1 as a common factor, and inside the brackets we have square root of 5 plus 1 over 2. So in conclusion, we got that x2 equals to square root of 2 minus 1 times square root of 5 plus 1 over 2. So in the next step we multiplied x1 by x2, but first of all I copied x1 and x2 to this page, and then we multiplied x1 by x2. Then I arranged the expressions here in a different way, and we got here that x1 times x2 equals to square root of 2 plus 1 times square root of 2 minus 1 times square root of 5 plus 1 times square root of 5 minus 1 over 2 times 2. Here we calculated the value of square root of 2 plus 1 times square root of 2 minus 1 according to the algebraic identity that states that a plus b times a minus b equals to a squared minus b squared. Here a equals to square root of 2 and b equals to 1, and square root of 2 plus 1 times square root of 2 minus 1 must be equal, according to this algebraic identity, it must be equal to a squared minus b squared when a equals to square root of 2 and b equals to 1. A equals to square root of 2, so a squared will be equal to 2. B equals to 1, so square root of 1 is 1 squared, 1 squared is 1, so it is 2 minus 1. So we found out that the value of this expression is 2 minus 1, that is 1. Then in this, we calculated the value of the expression square root of 5 plus 1 times square root of 5 minus 1 according to this algebraic identity. It equals to a squared minus b squared. A equals to square root of 5, b equals to 1. So a squared will be equal to square root of 5 squared, that is 5, and b squared will be equal to 1 squared, that is 1. And a squared minus b squared is 5 minus 1. So in conclusion, we found out that the value of this expression equals to 5 minus 1. And in conclusion, we got that x1 times x2 equals to 2 minus 1 times 5 minus 1 over 4, that is 2 times 2. 2 minus 1 is 1, 5 minus 1 is 4, and 1 times 4 is 4, and 4 over 4 is 1. Okay, here 4 over 4 is 1. So we found out that x1 times x2 equals to 1. Okay. In conclusion, we found out that x1 times x2 equals to 1. What does it mean? It means that x1 is the inverse number of x2 and x2 is the inverse number of x1. Okay? But according to equation number 3, we have already found out that x times y equals to 1. And again, it also means that x is the inverse number of y and y is the inverse number of x. And if we put the solutions for x1 and y1 inside this equation number 3, the first solution is x1 times 1, that is to say x equals to x1 and y equals to y1. And we got that according to equation number 3, x1 times y1 equals to 1. What does it mean? It means that y1 is the inverse number of x1. y1 is the inverse number of x1, but we have already found out that x2 is the inverse number of x1. So we have two numbers that are both of them are the inverse number of x1. And we have the rule that every number has only one inverse number. That is to say, x1 has only one inverse number. What does it mean? It means that the two numbers must be equal to each other. Okay? Otherwise, x1 will behave two different inverse numbers, that is not according to the rule that every number has only one inverse number, and because of that fact, y1 and x2 must be equal to each other in order that x1 will have only one inverse number. That is to say, y1 is equal to x2. And then we did the same process for the second solution. The second solution, we have equation number 3 that states that x times y equals to 1. The second solution is x2 and y2, so we put the second solution inside this equation number 3, x equals to x2 and y equals to y2, and we got that x2 times y2 equals to 1. What does it mean? It means that y2 is the inverse number of x2. But we have already found out that x1 is the inverse number of x2. And according to the rule that every number has only one inverse number, that is to say x2 and has only one inverse number. Therefore, the two numbers must be equal to each other. The two numbers must be equal to each other. That is to say y2 equals to x1. Okay? So we found out in conclusion that y1 equals to x2 and y2 equals to x1. And therefore, the solution to the question is that the first solution is x1 and y1. x1 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. And y1 equals to x2. Okay? So this is actually y1. That is also equals to x2. That is actually square root of 2 minus 1 times square root of 5 plus 1 over 2. So this is the first solution to the question, and the second solution to the question is x2 and y2. x2 equals to square root of 2 minus 1 times square root of 5 plus 1 over 2, and y2 equals to x1, and x1 is square root of 2 plus 1 times square root of 5 minus 1 over 2. Okay, so those are the two solutions to the question. Okay, thank you very much.